Welcome to the channel. Today we are traveling far beyond our solar system to a mysterious world orbiting a distant star, a planet that could be one of the most Earth-like worlds ever discovered. Its name is Kepler-160c. Before we begin this journey across the galaxy, make sure to subscribe to the channel and join our exploration of the universe. Because the universe is full of worlds we have never seen, and today we might visit one of them. The Kepler-160 system lies about 3,000 light-years away from Earth in the constellation Cygnus. That means the light we see from this star today began its journey before the Roman Empire even existed. Kepler-160 is a yellow star, very similar to our own Sun, and orbiting this distant star, scientists discovered a planet that might be capable of supporting life. A world known as Kepler-160c. The planet was discovered using data from the Kepler Space Telescope. This powerful space observatory was designed to search for planets orbiting distant stars. Scientists detect these planets when they pass in front of their star, slightly dimming the light. This tiny drop in brightness reveals the presence of a hidden world. In 2020, astronomers re-examined old Kepler data and discovered signs of a planet that had been hiding there all along. Kepler-160c is about 1.5 times the size of Earth. It receives a similar amount of energy from its star as Earth receives from the Sun. This places the planet in what scientists call the habitable zone, the region around a star where liquid water could exist. And where there is liquid water, life might also exist. Now imagine we are approaching the planet. Our spacecraft slowly descends through thick clouds. Below us, a vast alien ocean stretches across the horizon. The water might appear deep blue, reflecting the light of its distant sun. Green continents rise from the oceans, covered in dense forests of alien plants. But this world may be far more dangerous than it first appears. If the gravity on Kepler-160c is stronger than on Earth, life here would have evolved under immense pressure. Creatures on this planet might be incredibly dense, muscular, and powerful. Massive predators could roam the forests and coastlines, their bodies built low to the ground, supported by thick limbs and heavy bones, capable of surviving the crushing gravity. Every movement would require tremendous strength, and over millions of years, evolution may have created animals far stronger than anything on Earth. For a human explorer, such creatures would be extremely dangerous. Even a medium-sized predator could possess strength far beyond that of a human. In fact, the powerful gravity alone might already make this planet extremely difficult for humans to survive on. Walking would be exhausting. Running might be nearly impossible. Our bodies simply were not designed for such conditions. Yet evolution always finds a way. And if life had enough time to develop here, something even more extraordinary might exist. Intelligent life. A civilization that evolved under heavy gravity. A species stronger, denser, and perhaps far more technologically advanced than humanity. After all, the star and its planets may be billions of years older than our own solar system. If intelligence emerged there long before it did on Earth, their technology could be thousands or even millions of years ahead of ours. And somewhere on this distant world, they might already be watching the stars. If intelligent life evolved on Kepler 160c, survival would have been their greatest challenge. On a world dominated by powerful predators, they would have needed to learn how to defend themselves. Over time, this civilization may have developed powerful technologies and advanced weapons. Massive, heavily fortified bases could rise across the planet's surface. Strongholds designed to be nearly impenetrable. Within these bases, armed guardians would constantly stand watch, always alert, always prepared. Because beyond the walls, the wilderness still belongs to the predators. These defenses would allow their civilization to survive and grow, even on one of the most dangerous planets imaginable. But if intelligent life exists on Kepler 160c, survival would have required adaptation. On a world ruled by powerful predators and crushing gravity, intelligence may have become the ultimate defense. Over thousands, perhaps millions of years, an advanced civilization could have learned how to protect itself. Massive, fortified bases might rise from the surface of the planet. Cities built from incredibly strong materials, designed to withstand the planet's immense gravity and the constant threat of predators. Towering defensive walls, energy barriers, advanced weapons capable of keeping the giant hunters of this world at a safe distance. Armed guardians could patrol the outer perimeters of these cities, always watching the wilderness beyond the walls. Because outside their safe zones, the planet would still belong to the predators. Inside their bases, however, a highly advanced civilization might thrive. A society shaped by one of the most dangerous worlds imaginable. Standing on the surface of Kepler 160c, the sky might offer a breathtaking view. Because the other planets of this system may orbit relatively close by, on clear nights, several of these worlds could be visible in the sky, some appearing as bright, moving stars, others as massive glowing disks, far larger than our moon appears from Earth. These neighboring planets would slowly move across the heavens, creating a constantly changing cosmic panorama. Imagine looking up and seeing entire worlds hanging in the sky, their clouds, colors and storms visible even from the surface. A sky more dramatic and spectacular than anything we see on Earth. But reaching this distant world would be an enormous challenge. At 3,000 light-years away, even our fastest spacecraft would take millions of years. Future technologies might change that. Warp drives, antimatter engines, or massive interstellar generation ships. One day, humanity might truly travel to the stars. And worlds like Kepler 160c may no longer be just a dream. 3,000 light-years. A distance so vast it defies human imagination. To reach Kepler 160c, we need to move beyond chemical rockets and embrace the theoretical limits of physics. Generation ships. First, the generation ships. Massive floating cities, travelling at a fraction of light speed. Here, the journey is the destination. Thousands of years will pass, and those who arrive will be the distant descendants of those who left Earth. Antimatter engines. Then there is antimatter, the most efficient fuel in the universe. By annihilating matter and antimatter, we could reach significant percentages of the speed of light, cutting the journey down from millennia to centuries. Warp drives. Finally, the Holy Grail, warp drives. Instead of moving through space, we fold it. By distorting space-time, we could technically arrive at distant stars faster than light itself, making interstellar travel a matter of years or even days. The hook. Don't be mistaken, this isn't pure fantasy or some distant dream world. We are looking at propulsion systems grounded in the rigorous laws of mathematics and physics. The proof. On paper, the formulas already work. From Einstein's field equations to the Alcubierre metric, the blueprints for interstellar travel are already being written. The question isn't whether the laws of physics allow it, they do. The question is when our engineering will finally catch up to our calculations. The reality check. Until the day we finally reach these distant shores, much of what we imagine remains a grounded projection. Because of the vast distances involved, our visions are educated guesses at best. The possibilities. Kepler 160c might be nothing more than a barren, silent wasteland. Or it could be a world of emerald rainforests, breathing with plant life, but devoid of animals or intellect. Then again, it could be a mosaic of shimmering, futuristic cities, teeming with an intelligence far beyond our own. The conclusion. We don't know, not yet, but human curiosity is an unstoppable force. It is only a matter of time before we look into the cosmic mirror and finally learn the truth, whether we are truly alone or part of a much larger story. The time gap. But there is one more factor that shifts the odds in favour of life. The Kepler 160 system is an elder of our galaxy. While our Sun is 4.5 billion years old, this star has been burning for over 7 billion years. The head start. That is a 3 billion year head start. Imagine what a civilization could achieve with 3 billion years of extra evolution. When Earth was still a chaotic, lifeless rock, Kepler 160c, or its sister worlds, could have already been home to sprawling empires. The conclusion. Because it sits in the habitable zone and has enjoyed billions of years of stability, the probability shifts. We might not just be looking for life, we might be looking at our cosmic ancestors. In the end, Kepler 160c is more than just a coordinate in the deep black. It is a mirror. If a civilization there is truly 3 billion years ahead of us, they may have already mastered the very stars we are only now beginning to map. Perhaps we aren't the ones discovering them. Perhaps we are simply, finally, growing enough to answer a call that has been echoing across the void for eons. The journey to the stars is not just about moving through space. It is about the evolution of the human spirit. Today, we are the dreamers. Tomorrow, we are the ancestors of a galactic civilization. The stars are calling, but until we reach them, our greatest tool is our imagination. So, how do you picture Kepler 160c? A silent wilderness or a vibrant world of light and life? Let us know in the comments.